Hi guys, this is a model answer for the States of Matter triple exam question. A study investigated how the pressure exerted by a gas varied with the volume of the gas. Figure 1 shows the equipment that the student used. So you've got gas within this tube here, you've got a pressure gauge and you have got a pump here. The pump was used to compress the gas in the tube. As the volume of the gas decreases, the pressure of the gas increases. The student only recorded one set of results. Give 2 reasons why taking repeat readings could provide more accurate data. Okay, so for this one, what we can do if we do repeat readings is that we can identify and remove any anomalies. So identify and remove anomalies. If we only do one reading, then how do we know if that's right or if it's around what the mean reading should be? It also reduces the effect of random errors, so errors that may just come up and we might not have an explanation for them. They might not happen again if we repeat our experiment, so we need to check for that. And then the other one that we need to do is to be able to calculate a mean or an average. If you've put things like human error or reduces human error, that is no longer a valid answer to this question. Okay, so for the next one, Figure 2 shows the position of the student's eye when taking volume measurements. Explain what type of error would be caused if the student's eye was not in line with the level of the liquid in the tube. Okay, so this would mean that it would be a random error. Or we can also call this one a parallax error because it's to do with reading things from far away. Now, the reason it will cause a random error is because the eye position would not be the same each time relative to the liquid. Because the eye position would not be the same Okay, so that would mean if you're changing your eye position each time you're reading the scale from a slightly different place, your results are going to be all over the place and you're going to get these random or parallax errors. If the gas is compressed too quickly, the temperature of the gas increases. Explain how the temperature increase would affect the pressure exerted by the gas. Okay, so if we think about pressure increasing, it can be affected by temperature as well as volume. So if we increase the temperature of the gas, what we're actually doing is we're giving the particles more kinetic energy. If they've got more kinetic energy, then there's going to be more collisions with the sides of the container. So that means that we're going to have more force over that area, acting on that area, which will increase the pressure. Okay, so for our first mark here, we're going to say an increase in temperature increases the pressure. And then we need to explain why. So the reasoning behind that is at higher temperatures, the particles or molecules have more kinetic energy, which then is going to increase those collisions. Okay, one of the students' results is given below. He's found out that the pressure of 1.6 times 10 to the power of 5 pascals is equal to the volume of 9 centimetre cubed. Calculate the volume of the gas when the pressure was 1.8 times 10 to the power of 5. The temperature of the gas was constant. Right, so for this question, we do need our equation. The equation that we are looking for is PV equals constant. So the pressure times the volume of the gas equals constant. So when we have got a temperature which is constant with a gas, for the same gas, its pressure times its volume equals a constant. So I need to work out that constant first. I need to work out what that is. So pressure is 1.6 times 10 to the power of 5 pascals. And my volume is 9. The volume's been given in centimetre cubed, so just check that it's the same unit there and we don't have to convert. It is, so we're all right. If I work that out, I get 1.44 times 10 to the power of 5. So that's my constant. So constant equals 1.44 times 10 to the power of 5. Right, for the next part, I need to use that equation again. So I'm going to do P times V equals constant. I have my pressure this time, which is 1.8 times 10 to the power of 5. I don't have the volume, so I'm going to leave that in as V. But I do have my constant because I just worked that out previously. 1.44 times 10 to the power of 5. So in order to work out V, or volume, I need to do 1.44 times 10 to the power of 5 divided by the pressure, which is 1.8 times 10 to the power of 5. Just be careful when you are entering in figures in standard form into your calculator. The answer does come out as 8. So that shows us that we've increased the pressure and the volume has decreased, which is what we would be expecting. For the last part of the question, we've got a person using a bicycle pump to inflate a tyre. It says the internal energy of the air increases as the tyre is inflated. Explain why. Right, so if you've got anything with a bicycle pump or any kind of pump inflating something and it's telling you that the internal energy is increasing, it's because work is being done on the air in the tyre or the gas. Okay, so our first point is going to be work is being done or energy is being transferred. Work is being done on the air in the tyre. Remember that work done is equal to energy transferred. Sorry about that. So work is being done on the air in the tyre. If work is being done, or if we are giving more energy to these particles, then their kinetic energy is going to also increase. And kinetic energy is linked to temperature, so the temperature is going to increase as well. So therefore, the temperature of the air increases. meant increased kinetic energy. Also remember that internal energy is the sum of the kinetic energy and the potential energies of the particles. So if we are increasing kinetic energy, we are going to also be therefore increasing the internal energy. Okay guys, well done for completing that. If you have any questions, please email me and I'll try my best to answer them. Thank you.